Yo, Doug, I heard you liked analog technology.
Hey everybody, and welcome to episode 42 of the iPhreaks show. This week on our panel we have Pete Hodgson.
Good morning from Silicon Valley.
Andrew Madsen.
Hi from Salt Lake City.
Ben Sherman.
You have been fined 1 credit for a violation of the verbal morality statute.
James Zuber.
Hello from Minneapolis, and I've got 3 shells.
I'm Charles Max Wood from DevChat.tv, and this week we have a special guest, and that is Jeff Kelley.
Hello from Detroit.
I was so waiting for you to say that I said your name wrong.
That has actually happened to me one time. They said Khalid.
Okay. Do you want to introduce yourself for us?
Sure. So I do iOS apps for Detroit Labs here in Detroit. I've been doing iOS since about 2008 and wrote a book called Learn Cocoa Touch for iOS. It's about 2 years old now. It was iOS 5, so you should probably find a newer book if you're getting a book right now. But yeah, that was published through Apress, and now I just do iOS apps full time.
Awesome. So we brought you on to talk about concurrency. When I hear concurrency, I think threading.
Mm-hmm.
Is that generally the way most people go, or is that just me?
Yeah, I tend to view concurrency as solving a problem. So the typical problem is I push the button and it takes a while before the thing is done. So threading is one approach to that. You can also use like GCD, NS operation queue. I'm sure we'll get into those. But it all starts out with, I have this thing that I want to do, and I don't want to block the main thread to do it.
Okay.
So maybe a good way to start would just be to kind of enumerate what our options are for doing stuff concurrently or in parallel or whatever in iOS.
Sure. So, and pretty much everything I'm going to say also applies to OS 10, since they share so much. So we'll start at the bottom. We've got anything you can do in the standard Unix threading model. So if you really want to spin up like P threads, go for it. That all works just fine. So you can have multiple threads running code at the same time. There's an object-oriented model on top of that NS thread that gets you the nice Objective-C interface to it. Most people don't use that these days. You'd use a thread if you needed something going in the background, just kind of spinning through a loop or waiting on an event. Most of the time now, people use either Grand Central Dispatch, which is a C API for dispatching blocks. That's pretty good. There's some overhead in learning it because it's C-based, not Objective-C. So if you're not used to a C API, there can be some gotchas. And then on top of that is NS operation queue, which is a further abstraction of GCD. And the idea there is you have operations that are little tasks that run on queues, and you can enqueue them and wait for them to finish. And then finally, there's just API level stuff. So if you're sorting an array or enumerating a dictionary, there are API calls you can do that do those concurrently without having to set anything up.
What is like your decision point on like when to use what?
I always try to use the highest level thing that's going to work for my needs. So if I can get away with just using the NS Dictionary API, I'll use that. If I need to drop down to an operation queue, I'll do that. A typical example of an operation queue scenario would be I need to download an image, and that download itself, I'll probably use AF networking, and that'll be its own NS operation, and that'll run on a network queue, so I don't have 1,000 network requests going out at once. And then let's say I need to resize that image, so that would be a separate operation that would run on maybe an image resizing queue, and then finally use that image once those are both done.
So just using that as an example, like how would you structure that? I know there's like dependencies between NS operations, or you could just have one operation call back and then queue up the second one with the output of the first. How do you typically set those things up?
Right. So that's the big feature of NS operations is those dependencies, especially that they can traverse multiple queues. So I can set up a network operation, and then immediately after I set that up, I can set up the resizing operation and just hook up the output from one to the input of the other. And then I'll put the second one on the queue first, add the first one as a dependency, then add the first one to its queue. So that I ensure, especially with the 64-bit simulator, I've noticed that sometimes it can run so fast that your operation finishes before you have a chance to add it as a dependency. So you kind of work backwards. Yeah. So you get the final state set up, add the dependencies, get those set up, and then finally you get the first one that you actually start.
And how do you correlate the output of the first? Like, how do you pass that data from like the downloaded image, for instance? Because like one option for creating an NS operation is just to like take data in your constructor. But if you've already created the operation, then how do you pass it along?
I'm big on properties. So, an image download operation might have some properties like a UI image or an NSString for a path. And then I'll just set those in the operation so that when the next one goes, it has a property for the first operation and it can grab what it needs. And then if those are nil, then I know that there's an error that's happened. You can also do block operations. So you just initialize the operation with a block. And then in the scope where you make all of those, you can define some variables that you set that are passed from one to the other.
So is the setting of that dependent, like the dependent operation property, is that something you would set up yourself? Or is there any kind of facility built in for getting a reference to your dependent operations?
That's something I would set up myself. There's probably a library somewhere on GitHub to do it.
So GCD is taking responsibility for putting things on the right thread and then kind of firing off your NS operations like in the right order. But your code is responsible, or the code that we write is responsible for actually moving kind of data through that pipeline. Is that right?
Correct.
Okay. Huh. I wonder why they don't just, I kind of was hoping that you were going to say, and then it just magically appears as a, as passed in as parameters to a function or something.
Yeah, there is a GCD data type. It's like dispatch data. And so you can use GCD to pass data around, or if you have a huge data set, you can operate on individual parts of it concurrently. It's pretty low level of an API, so you usually don't need to do that unless you have extreme performance needs. Typically, it's just easier to get those things in the operations. Or a lot of the times what I'll do is I'll have, like for downloads, I'll have an algorithm to say this is the file name of the thing when it's downloaded on the file system, and just use that file. So if I'm downloading a 2 gig image, I'm not going to keep that all in memory. So I'll have an output stream that just writes that image to the cache, and then I'll know the path of that image when I go to load that in image.io to resize it.
Okay, so the file system kind of is your scratch pad for moving stuff between these different asynchronous
Exactly.
operations.
Yep.
Cool. If you're doing stuff with just setting properties, do you have to do anything special because you're passing things kind of potentially across thread boundaries? Like, do you need to do some magical invocation, or can you just set the property just as if it was all running in the same thread?
Yeah, most of the time you can just set the property. So the nice thing is that when you set up an operation as a dependency, it won't start the second one until the first one says, I'm finished. And so as long as you set all your properties before you say you're finished, then it's a read-only situation.
Okay. And does GCD have any kind of built-in capabilities for doing kind of stuff in parallel? Like if you wanted to say, let's say you've got some huge, this is a silly example because it's always the example people use, and I'm not really sure why you'd ever do it on an iPhone, but you've got some huge array and you want to kind of do some expensive operation and you want to light up all the cores of the iPhone. So you want to run kind of four calculations in parallel across that array and then kind of join all the results together at the end. Is that something where you're going to be doing most of the work yourself, or is there some magical API that Apple have provided to help with that?
There is, in fact, a magical API. So the first thing you do is you would say dispatch get global queue. You'll get a background queue with a priority from high to low. And then there's a function you can call called dispatch apply. You basically tell it, I need to run this n number of times on this queue, and here's a block. And the block is what gets called every single time. So you'll have your index there, and then you can operate on your array of data. And that will do the thing where it automatically scales to the number of cores, and it makes sure that you're not.
Oh, neat.
It does make sure that everything isn't waiting. So let's say you have 8 cores on your Mac and you run that, and every single core is waiting on the disk. It's smart enough to spin up more while those are waiting to use the CPU.
Oh, wow. That's pretty awesome. That's pretty kind of advanced stuff.
Yeah, and the really nice thing on OS X, I mean, you don't really see this on iOS because there's only one app really running, but is that every single app has the same kind of global background queues to use. And so the system is really smart about like looking at the picture holistically and making good decisions about which processes to prioritize. If you were writing NS thread, every single app would have to do the horrible step of finding out how many CPU cores there are and then trying to find out how busy those cores are and trying to figure out how many threads I should spin up. And now I've got to dispatch work onto those threads and make sure I don't get the CPU too busy. And it's a lot of work. And importantly, it's a huge surface area for bugs. And those are like the worst bugs. So you don't want to write that code at all.
And presumably, like, if you're running, on an iPhone in particular, on iOS in particular, you don't have that kind of higher level perspective because you can't see what other processes are doing kind of for security reasons. So, right. Whereas the operating system obviously does know what everyone's doing. So it has enough knowledge to manage things a little bit better than you would be able to in your own application, I suppose.
Yeah.
Jeff, I have a question.
Sure.
So I think we're talking mostly about NS operation queue and NS operation so far. And I'm a little curious to know why you would use the CGCD API in favor, instead of NS operation. Is there a good reason why you want to use the C API or cases where it does things better?
Yeah. So one canonical example is all of the the dispatch async and the dispatch sync. Those all have function pointer equivalents. So if you already have some Unixy library you're using that's C, you can just pass in a pointer to a function you want to call instead of a block. And that can be pretty powerful if you have legacy code that you want to integrate. Most of us don't, though. Most of us are using newer APIs than that. But there are some things you can do in GCD that you can't do with operation queues, or at least you can't do easily. So one really powerful example is making any class thread safe easily. You can make a separate queue for, let's say, accessing an array. And anytime you want to read from that array, you just call dispatch sync with your queue and you read from the array in the block. When you want to write to it, there's a separate function called dispatch barrier async or sync, and whichever you need. And the barrier, what it does is it clears out everything in the queue before that block runs. It runs the block, and then it runs anything else. So it's a really cheap way to make sure that whenever you write to an array or a dictionary or just a value, that you only ever write when nobody is reading. And then you can read concurrently because you're not changing anything.
So it's a sort of mutex or semaphore. It's just a way of locking the data structure so that nobody else is touching it while you're writing to it. In other words, it makes the operation atomic.
Yes. And GCD is really good at stuff like that because it's so low level and it's so built into the system. A good example is dispatch once. It's used in singleton initialization code a lot now. However you feel about singletons, that's how, if you're going to make one, that's how you should do it. When you call dispatch once, you give it a block and a token. And for that token, it will only ever call the block once. And if you hit that for multiple threads while that block is executing, it'll just wait until it's done. And then finally, once it's finished, if you call it again, it's just the no-op and doesn't do anything. So at the kernel level, it's giving you a way to make sure that block only ever happens once. Because a lot of the time with singleton code, you might see two threads call the shared instance method at the same time. And so it'll go through and make a new singleton twice. And then, the second one that runs is the one that wins.
And now you have two problems.
Yes.
So for the dispatch barrier stuff, is it locking on the object that you're operating on, or is there some magic where how does it know to correlate those two, the reads and the writes? Is it based on just the array that you want to read from?
It's based on the queue that you dispatch to.
Okay.
So, the queues are pretty lightweight. They've actually kind of behind the scenes become objects, but not really. But yes, because if you have Arc, you can't release them. But they're pretty lightweight, and they're lightweight enough that if you have a small amount of objects, not 1 million, but 10, there's, almost no cost to making a separate queue for each of the important properties you want to hit. Or even just a queue for all the properties of the object, and then they can kind of just share.
And so when I'm creating those queues, I'm actually creating, let me kind of try and talk through what I think you're saying. So let's say I have an object that I want to be accessed from multiple threads for whatever reason. So I want to make this object thread safe. So what I could do is create, for each instance of that object, create a queue and assign it, store that queue essentially in as a property of that object. And then whenever I try to access stuff internally, my getters and setters would have to kind of do stuff through those dispatch methods. Is that right, or am I doing it wrong there? Yep,
that's pretty much totally right. I definitely would, I try to make sure that that queue is never exposed outside the object. So if it's a property, it's going to be in the class extension.
Gotcha.
And then, from the outside, all you see is a property and it's marked non-atomic. But on the inside of the class, those getters and setters then call into that dispatch code.
Oh, so that's a good question. So the atomic, non-atomic doodads that you set on a property, what would be my motivation for doing this stuff kind of manually with a queue or with the dispatch stuff in a queue rather than just using that atomic doohickey, whatever that thing is called?
So for that atomic, let's say you have an NS array. So the pointer to the array itself is atomic, but if it's mutable, then the stuff inside of it is not.
So I could atomically access it and then mess with it while someone else has atomically accessed it and is messing with the internals.
Exactly. Yeah. So if you have like a float, you don't need to worry about it as much. It's just, it's a space with bits in it. But if it's a pointer to a mutable array, then you really need to worry.
Gotcha. So that's why you should probably use NS array rather than NS mutable array, maybe.
Yeah. Yeah. So even if the public facing property is an NS array and the internal, IVAR that you use to store it is mutable, that works fine.
Except someone at some point is going to cast that NS array into a mutable array because they think they know what they're doing.
Yeah, and then you just stop working with those people.
Yeah, right. After you've spent 2 weeks trying to nail down this weird concurrency bug that only happens when your boss is watching.
Right. It only ever happens on the CFO's phone, and he's got a 3GS, and you don't understand why because he's the CFO, but that's how it always happens. And that's another good point, is that these bugs with concurrency, they're very hard to reproduce. You'll see someone say, well, I had this thing and I pushed the button and one of those times it crashed. And that's like as much as you get. So one of the things you want to do for debugging purposes is anytime you make a queue, both for GCD and NS operation queue, you can give them a label. So for GCD, you'd use like com.example.download queue. Then when you're in the debugger in Xcode, you can actually see that label when a block is running, so you know what queue it's in.
You got any other tips for, like you said, reproducing these things can be, if you do have some kind of concurrency bug, reproducing them can be a horrendous exercise. Have you got any other kind of tips for either tricks to reproduce these kind of intermittent things or tips for debugging them once you have reproduced them, apart from that one?
Yeah, so the number one tip is, you have a data set of test data that you're going to use, and you want that to be like the largest data set that's ever processed. So somebody comes to you and you're expecting someone to have, let's say, 1,000 items in a shoebox app, and they've put 1 million in, and you never planned for that. So as soon as that happens, you want to make sure that your data set has 2 million and that everything works fine. And also for testing, so I do a lot of TDD and we use Kiwi. It's tempting. You can write these like a unit test. You can say like, this thing should eventually equal this thing. And then you start code that schedules a block. And what we've found is like, we've got a Mac Mini for our CI server, and it's really slow because it's a Mac Mini. And the timeout on that should eventually in Kiwi, where it says, I'll wait 5 seconds until I finish this. And, it's not long enough on the Mac Mini because it's so slow. So the thing to do instead is you want to test first off that the block got scheduled, that everything started. And then you want to test the code that's going to run when it finishes itself in isolation. So you can test both of those things synchronously and you don't want to test GCD or NS operation queue. You can assume those pretty much work. What you want to test is your actual code.
You can't see it, but my head is nodding furiously along with all of those statements. There's a really good pattern around that called Humble Object, I think it's called, which is around trying to constrain your asynchronous stuff. That stuff that makes something asynchronous or run on a different thread or whatever. Like try and keep that to just the plumbing code, and then have the actual work that's being done kind of separate. So that you can test that synchronously and not have to deal with all of these wacky issues with threading and blocking and waiting and all that junk. And then you can have maybe a few high level tests that verify that you're using GCD or whatever correctly. But
yeah, and that's a nice thing about NS operation, because instead of making one with a block, you can make a subclass of NS operation, and then you just implement the main method. And that's really easy to test on its own. In your test, you just call main, and you never have to schedule it.
Yeah, I'd almost say that NS operation is an implementation of that humble object pattern, actually.
Yeah.
Yeah, cool. I haven't thought of that before.
The one tricky thing with NS operations and testing is that the state is, so you have like is finished, is executing, is canceled, and all of that uses KVO. And so it can be, tricky to test with KVO synchronously because you'll set something and then the notifier is scheduled, but it's scheduled asynchronously. That's a gotcha to watch out for, but there are other ways around that.
So we talked about like downloading images and resizing them. We talked about like coordinating access to a shared resource with barrier blocks. What other types of, core data comes to mind, but are there any other types of operations where, concurrency is a natural fit?
Yeah, so right now I'm actually running an app using OpenGL, and it's got several different objects. And for each of these objects, I need to do several things. I need to download the vertex data. I need to download several textures, and then I need to load all of that into graphics memory. And OpenGL, it's kind of like core data in that for every thread you use, you have to make a separate context. And so when I download all this data, I don't want to parse a texture file or the vertex data on the main thread because I want my UI to stay responsive. So you can spin up a separate queue or a separate thread and make a new GL context, but they share the same data across them in what's called a share group. So I can do the parsing and the loading into memory on a separate queue, and then when it's done, I can actually start drawing it on the main queue.
That's pretty cool.
Yeah, I mean, basically you want, like every single method should try to get off of the main queue as quickly as possible. Like it's still got to do what it says on the tin, your load data method still needs to load the data, but like a secondary goal should be that load data method should return as fast as possible. And if it needs to schedule something in the background, that's fine.
Now, you said that you need to set up a separate context for each thread. What exactly do you mean by that?
Yeah, so OpenGL, it uses a GL context. It's a state machine. And so you call these C functions that then set the state, and they all operate on, what's the current context. And that has to exist for you to call anything. And so what you would do is in your initialization code, before you start your task, you would just make a new context. You have what's called a share group, and you would make it with that share group from the main context. It's pretty analogous to core data, where for each separate queue or separate thread, you would make an NS managed object context and then pass around object IDs instead of objects.
Yeah, that's a pretty common pattern in core data, and one that will probably bite you in development, so you would notice, but not always.
Yeah.
And I think those are like kind of the worst types of things where you're like, oh, it works, ship it.
Mm-hmm. Yep. And, often, as developers, in crunch time, we get backed up and we just want to ship. And so we'll test it with a very small data set under ideal conditions. So you want to test with a large data set on the worst possible device you can run on. So if you support the second generation iPod Touch, run on that with 1 million objects. Especially with concurrency, because the simulator is a simulator and not an emulator, it's going to use all your cores. So if you have an 8-core MacBook Pro, it's going to run on 8 cores, and that can hide problems that you see on an iPhone with 2 cores. And if you have, the new Mac Pro with 12 cores, that's 24 virtual cores, and you're really different from an iPhone at that point.
Yeah, I guess.
But if anyone wants to buy me one so I can test that out, I'll happily blog about it.
Like a fair trade.
Yeah. So is the only option you have for concurrency on an iOS device threads, or can you actually fork the process?
Yeah, I've never actually tried to call fork. I would imagine that's disallowed on iOS. I don't think that there's the usual Unixy style scenario where you would actually want to fork, but that is a good question. I would say probably not.
We had this discussion at Cocoa Heads recently, and the consensus seemed to be that, the fork function is available, but if you call it, bad things happen. It doesn't really work the way you would expect, and fork is even hard to use on a system that does support it, like OS X. It's not a simple beginner API kind of thing.
Yeah, if you follow the viewpoint of I'm going to use the highest level API possible to succeed, and you get all the way down to forks, then I think that's when you need to start to reconsider the problem you're solving.
What about on OS X?
Yeah, so on OS X, forks are just fine. They work as you would expect. I used to, before I did iPhone stuff, I worked as a Mac sysadmin, and we used a portable C library I guess you'd call app now, called Radmind, and it made use of forks, and they work just fine. But a lot of the even command line stuff on OS 10 is moving towards GCD. So where you would have like a run loop on your event-driven OS 10 app, you can also start an app just straight up GCD. A good example of this, if you go to the Apple open source page, I think it's in one of the system libraries. There's an open source utility called Caffeinate that's on your Mac. And Caffeinate is responsible for keeping your Mac awake if you need it to stay awake. And the code for that is available. And that's an example of an app that instead of calling like nsrunloop run, it uses GCD entirely.
It's called Caffeine.
Caffeine is the menu bar app.
Oh, okay. This is a different one then.
Yes.
Okay.
Yeah, Caffeine is a third-party app, and does the same thing, but it sits in the menu bar.
Hey, look at that. I just found a command line thing called Caffeinate. I never knew that was there.
Yep. So the code that it finally ends up calling is dispatch main, and that takes place of like the NS application main or UI application main that you'd be used to.
Yeah, that's interesting. So talking about run loops, there used to be like it was more common before GCD, but you would do stuff like perform selector in background or perform selector after delay. And so it'd be a way to sort of, I need to do something, but I need to finish what I'm doing first. And so there would be some like subtle bugs that you could fix sometimes by just saying perform selector after delay 0, which would just schedule it for the next like run loop. And I'm wondering if you could shed any light on like how run loops are used, because there's a way to do concurrency like where it's still done on the main thread, but it's not done in the user interface portion of the main thread, if that makes sense.
Yeah. So, the run loop, it sits there and it loops through, as the name implies, waiting for events. And those events could be timers firing. They can be the user interacting with the app. And when you do something like perform selector after delay or perform selector on main thread, it's just scheduling that to run in the run loop. Another good run loop trick is like ns run loop, current run loop to get the current one. And then on that, you call run until date and you pass in the current date. And at first, it seems like that doesn't make any sense. Why would you run it until now? But what that does is it kind of flushes the queue of everything that's been queued up until this point. And so some of those subtle problems you mentioned where there's like a race condition can be solved that way. Apple's gotten pretty good about adding completion handlers to some things that cause that. So one common one used to be like presenting a modal view controller on iOS. And now when you do that, they give you a completion block that you can pass in to run something when it's done. And that's definitely preferable, right? Because anytime you see like perform selector after delay, or now there's a GCD equivalent called dispatch after, that's a code smell. That means that there's some kind of race condition that you weren't able to fix with an actual API. And so you should look at those. And if you just actually can't solve it, file a bug with Apple or try to solve that problem in a different way.
So, we talked about processes and forking processes, and I seem to remember I can't remember if it was last year or a couple of years ago at WWDC, Apple were talking a lot about XPC, this kind of idea of separating out your, I guess they were mainly talking about it on the OS X side of things, and that they had this kind of, this pitch that you should make small processes that were intercommunicating with this new fancy XPC thing, and then like they wouldn't have, if they crashed, then they would magically not really crash, and if they got you could do privilege separation, which I guess is what grown up Unix servers use to reduce the attack surface for viruses and that kind of stuff. I guess that sounds kind of like what we were just talking about with forking processes, but I'm not even sure if it offers a different way to manage these interconnecting processes rather than forking, or is you still left to do that low-level Unixy stuff?
Yeah, so all the different processes with XPC kind of run on their own. The nice thing is you can get on OS 10 LaunchD. This is kind of the launcher daemon that lives in the system. That will be able to restart them and launch them when the system starts. And so it's just kind of separating all of that code, because with the app that draws the UI on your screen does not need to be the same app that installs system components, right? So it's not so much about concurrency as it is about good code separation, but there are some nice concurrency benefits from it, because when your model is that your process sends a message to another process, like there's asynchronicity built in right there. So if the other process spins up 8 threads before it finishes the task and then calls you back, that's fine. You don't need to know that.
And presumably a lot of those calls between processes are asynchronous. Well, I guess I'm assuming that, but maybe I'm wrong. Like if I have like a little worker process that does image processing, for example, or maybe that's a bad example. Let's say, go with a security thing. Let's say I have a small kind of process that's just responsible for saving files to disk or something. And I wanted to, from my main process, kind of ask it to save the file. Would I kind of fire that off and then wait for it at some point in the future to come back and say, hey, I'm done? Or can I still kind of keep my nice synchronous programming model of just calling a method and having it return a value?
Yeah, and this is where the fact that I don't use XPC a lot is going to bite me. But one thing you can do is use like distributed objects. So you can have one process with an Objective-C object that sends a message to another one, and that other object happens to live in this other process. And it just browsing the documentation looks like that works fine. But you can also just send like a sig kill or something like that. So not using it a whole lot, I'm going to say yes, you can do both.
There are actually kind of 2 APIs for XPC, and the newer of the 2, which came out in 10.8, is all Objective-C. The older one is C only. With the Objective-C API, you can send messages to objects in the other process as if they were just objects in your process. But there is a restriction that those methods all must have a return type of void. So if you want to pass data back from a method, it is done asynchronously, and you have to do it using a completion block or that kind of thing. I don't know if I articulated that well, but hopefully. No,
that makes sense. So I can't ask a process to do something and get the result back immediately, but I can ask the process to do something and know that the other process received that message and is doing it.
Yeah.
Okay. Is any of this stuff available for iOS? I know that for system stuff, I think it was with iOS 6, they started using XPC for things like the mail kind of, the stuff where you're invoking kind of system-y things like sending mails or browsing photos or whatever. But as far as I remember, there wasn't actually any way for a lowly non-Apple developer to create their own XPC things.
Yeah, and that's still the case. The only way that's, officially sanctioned to send data from one app to another is either a URL scheme. So I launch this URL and the system switches apps to this other app and then does something with it. Or you can use inter-application audio to send audio data. And there's an app called Audio Bus that's really nice for automating that. But there's no straight up XPC that you can use, right? So if you actually look at the classes and you look at what's going on, that view controller that comes up for making a new mail message, that is XPC, and it's like a UI remote view controller. And that would be a fantastic API for us to be able to use, but at least right now we can't.
It's also really frustrating if you're the maintainer of a test automation framework, because suddenly you can't actually automate any of that UI, which makes people who use your test automation framework very mad at you.
Yes, and that's another case where the best you can hope for is this thing was called correctly. So in your test, that's an opportunity for a mock.
Yeah, unfortunately, in my case, it's a UI testing framework. So literally, the test is like, tap this thing over here, fill out an email address, etc., etc. Which for email is okay because you shouldn't really be sending emails anyway. But for some of the other stuff, it's like suddenly I can't test photo browsing anymore because Apple introduced this new thing.
Right, and you could go as far as to have a compiler flag that's different when you're going to run it in that test harness, but at that point, you're not actually testing your production code, you're testing your test code.
Yeah, right. Yeah, which is the trade, is always the trade-off with that. I guess you hit that trade-off a lot with concurrency things and testing. At some point, you've got to kind of decide whether you really want to test it or whether you're happy with, like you said earlier, trusting GCD to do its job or trusting the frameworks to do their job.
Yeah, and one way you can kind of get around that is you can actually mock on NS operation queue. So you could stub out the main queue method and return your mock queue, and then make sure that things get added to it correctly. And it seems like when you're doing it in Kiwi, you're actually replacing the method that main queue calls with a different one, and you're like, is this going to work? Is this going to like completely hose my system? But it works just fine.
Kiwi's pretty magical, I guess. I wonder how they do that. I have no idea. I guess they know they can hook into because they're the test runner as well, they can remove any monkeying around that you did at the end of the test so that you're not permanently hosing you're not doing like old-fashioned method swizzling where you've now kind of you've permanently kind of shut the door on yourself or whatever.
Yeah, so the way that it works is they do a lot of like invocation parsing and manual message forwarding, and they keep like a stack of all the changes you've made, and then when that block exits, it pops the stack and it undoes those changes.
Neat.
So one question that I run into a lot is generally for most apps that I write, they're pretty simple. And so, having something block the main thread for a half a second or something, or not half a second, but, a few milliseconds isn't going to hurt anything. And so at what point do you really need to start considering whether or not you need this kind of concurrency?
I'd say that 2 milliseconds absolutely does mean something, because if you're trying to animate something like a table view at 60 frames a second, then if you do the math, you have, 16.7 milliseconds per frame to do your work. And so you really don't have a lot of time to actually do all that animation. And if your drawing takes 10 milliseconds and data processing takes another 4 or whatever, then you're already like up against that limit, and you're going to start dropping frames if you add any more work in there.
Yeah, as somebody who's like fussing with OpenGL shaders, I literally had 1 divided by 60 open in Spotlight to get that same number out, because it definitely is important if you don't ever want to drop a frame. And it's a trade-off, right? So if your application is going to be used by 15 people in an internal department where they just verify stuff with their phones, sure, 2 milliseconds is fine. But like if you look at Facebook and the Paper app that just came out, like they've got potentially what do they have, like 1 billion users? They need to make sure that it's going to look really nice on everybody's device, on jailbroken devices that have weird background processes running, and on the oldest ones they support. As far as when you should decide to start investigating this, it all starts, with using instruments, and especially there's the time profiler one where you can actually see how much of your app is spent in each method. And, it's just like find the expensive parts of your app and either make them less expensive by better algorithms or put them on the background queue so that it's okay if they take a while. I'm definitely not a fan of just making things concurrent because they can be. You should always write the code for a reason and to solve an actual problem.
Yeah, I think there are 2 rules of concurrency and using threads. First is never do it. Second is C rule 1, I think. That's pretty much it. There's the third rule. If you really, really need to, then probably not anyway. But if you have to.
If you have to ask, then don't do it.
The only code I can think of that I use right now that actually uses NSThread, I think AF Networking maintains its own thread to listen for network callbacks. And that's pretty much it. Everything else that I do can be expressed as an individual discrete task using operations or just GCD.
So do you recommend using like operations for even like simple things like bringing up a view controller? I have to do some relatively long running process, half a second, and then pop to the main thread and do something. Do you recommend doing an NS operation queue or NS operation for something that simple?
Obviously depends on what you're doing, but if the thing I'm doing is, let's say load some cache data and then display a view controller, the nice thing about, even using NS block operation to do some lightweight operations with blocks right there is that it's really easy to refactor. So if I make this long running operation and then I set that dependency of the showing the view controller code, at any point in the future, I can refactor that out to be its own subclass of NS operation without going through and changing all the plumbing of how that system works. So instead of defining the block right there, I would just say make a new operation subclass of this kind. So even for simple things, doing it that way when you need to do anything asynchronous sets you up in the future for success.
Okay, so down the road you can make modifications as needed.
Mm-hmm. And it also avoids problems with like every Objective-C developer's first completion block where they retain self inside the block and the compiler warns them that they shouldn't do that. It avoids those kinds of problems because you're separating all the things you need to do.
Okay, very cool.
And then another good thing about the operations is with those cross-queue dependencies, let's say you're developing the app locally and then you want to use network data. So you still have your display the view controller code that's scheduled on the main block or the main queue, and it's got a dependency of this load cache data operation. And you can go in and add another operation, which is the load the data off the network operation, and then set that as a dependency of the cache data loading operation. And so without changing the initial code that shows the view controller, you've added a separate network layer.
Okay, so at the point you need to start chaining operations together, then that allows you to do that pretty easily.
Yep, and another common thing I see with GCD where it falls down for people is waiting for a bunch of different operations to finish, right? So if I have 10 objects and I need to make a separate network call for all of those, and then when all of those are done, I need to do something else. It can be a little bit tough with GCD to get the mechanics right on doing that. There are like GCD semaphores you can use that control access, but it's a lot easier to just make an array of operations and add them all as a dependency.
That's a good approach. My first approach would be to yell at the architect.
Yes, there's that. Unfortunately, we don't always get to write the web services too.
Nope, but in a perfect world, everyone does what I say.
Yes. We have some clients where they've got people to write web services, but they ask us, what should this JSON output look like? And we really like those clients.
Got one last random question. Is there any kind of considerations to do with kind of battery life around this? Like, am I going to potentially drain my user's battery more if I'm using all of this fancy pants multi-threaded stuff?
Yeah, so you definitely want to be mindful of that. You want to run your app through the battery life instruments. At the end of the day, there's stuff that you need done, but there's things you can do with concurrency, like batching all your network requests to be together. And some of the new things Apple's doing in iPhreaks, like with timers, that you can say, fire at this date, but it's okay to give it a little bit of wiggle room. For iOS, worry about the battery life, but first off, worry about doing what you actually need to do, and then see if you can optimize it by doing things together more than separately.
Gotcha, that makes sense. So that's all like the coalescing stuff that they're doing now with like turning on the radio once rather than 5 times.
Exactly.
All right, well, let's go ahead and get to the picks. Andrew, do you want to start us off?
Sure. I have 2 picks today. My first one is it's actually issue 2, which is a little bit of an old issue now of Objective-C.io. If you haven't read Objective-C.io, it's worth going through and reading all their issues, but they do, I don't know how often they do this, but they do an in-depth issue about a single topic in Objective-C and Cocoa programming, and issue 2 was all about concurrent programming, so I think it's relevant and very well done, and it talks about all kinds of things related to concurrency in some depth. My second pick is Cocoa Heads. Cocoa Heads is an international, sort of really loose international organization of local chapters that meet once a month for presentations and to hang out and whatever and talk about Cocoa and Objective-C. And I go to Cocoa Heads every month. It's how I know Chuck, and it's just worth checking out if you've never been. It's a great way to meet new people that are doing the same kinds of things you're doing and learn new things. Those are my picks.
Awesome. Pete, what are your picks?
Okay, my pick. So my first pick is something I mentioned earlier, that this is the humble object pattern. So this is captured in a book called XUnit Patterns, which is this huge encyclopedic book. It's quite intimidating, but luckily it has a nice website and you can go and kind of dip in and out of it. And because it's patterns, you can just read one and then you don't have to kind of, kind of small, self-contained little ideas. And humble object is a good one. It's kind of a little bit like NS operation kind of embodies this. So I'll add a link to the page on the XUnit Patterns website, and people can read that if they feel excited about humble objects. My other pick is a bit of a mind-expanding one. Talking about all this stuff about concurrency makes me think about shared mutable state and how that's a bad thing and it causes us no end of pain. And if we could only not mutate state, then our lives would be so much better in a concurrent world. And Rich Hickey, who's the guy who wrote Clojure, understands this very well, and he has a very good presentation where he talks about how Clojure manages this with these things called persistent data structures. So these are also kind of called shared state data structures. They're nothing to do with persistence in the database sense of the word. They're more about making things that are immutable and that are very cheap to copy around and change. It's really, really cool stuff if you're into that kind of thing. And then my last pick is a food item. I've recently been really enjoying Trader Joe's chili spiced mango. It's really nice. It's spicy. It's sweet. It fills you up. So that's my last pick.
All right, Ben, what are your picks?
So I was really depressed over the news this weekend when Philip Seymour Hoffman died. He was one of my favorite actors. So I'd like to pick two of his movies, which are just good movies in general, but his role in those movies were awesome. The first one is Big Lebowski, and the second one is Almost Famous. So if you are not a Philip Seymour Hoffman, or if you don't know a lot of his movies, you probably have seen like 10 or 20 already. He's just got an impressive career of movies. So go watch a movie this week. And my third pick will be a beer pick. I've been really enjoying Union Jack IPA by Firestone Walker. It's delicious.
That is a very good beer pick, Ben.
I aim to please.
I drank one of those last night and I was thinking to myself, I should pick this beer. I pick you.
All right. James, what are your picks?
Okay, I want a +1. Ben's pick on his role on Almost Famous. Though it's kind of odd because he played Lester Bangs and they passed in similar circumstances. So that's kind of odd coincidence. But I'm going to make a beer pick. So I was at the store picking up one of my favorite breweries is Weyerbacher. And they've got a Belgian triple they do called Merry Monks. It's pretty fantastic. And I had forgotten that I had liked it so much when I bought it a year ago. I'm like, oh, they made a triple. And I looked at it, I bought it. I tasted it like, wait a minute, this is that fantastic thing I drank a year ago. So it's very good. So try it out. Weyerbacher Merry Monks. Those are my picks.
All right. I'll jump in here with a few picks. One of them was something that was referred or recommended to me the other day. It's called focusatwill.com. And basically it's this, I don't know exactly how to describe it. It's kind of a music service, except they actually have a science page here. I'll put a link to that in there as well, that explains the science behind how they pick the music. But what they basically explain is that it helps you shut down your limbic system and stuff. And anyway, it sort of shuts off your fight or flight center of your brain and allows you to focus more. And so I've been trying it for the last day or two, and I really do feel like I can focus more, but I'm not completely convinced yet whether it's the science, whether the science is good, because I don't know anything about neuroscience at all, or whether or not there's some kind of like placebo effect or something else. But anyway, it's kind of scary how focused I did get yesterday at one point while I was listening to the music and just working through some of the stuff that I was doing. But anyway, I think it's pretty cool, and I'm probably going to keep using it. And so I'm really, really enjoying that. Another pick I have is Discourse, which is an open source forum software that's written in Ruby on Rails with an Ember.js front end. And I really it's easily the best forum software I've used. I'm actually using it for the Ruby Rogues Parlay group, which is a discussion forum on Ruby centered around the Ruby Rogues podcast. I also have one for the JavaScript Jabber podcast. I'm considering opening one for this show so we can discuss iOS stuff in a forum on a regular basis. If you're interested in that, just send a tweet to @iPhreaks and just let us know that you would like to have that kind of a forum. The way that we've done that on the other shows is that you can either sign up for various levels. The lowest level is $10 a year. We found that that's basically enough to keep the trolls out, and then you can choose a higher level of donation if you want to give back to the show. And so if you're interested in that, then I'll go ahead and set that up. But I want to make sure there's enough interest to get a bunch of people into the forum and get some discussions going, so that it doesn't kind of turn into this dead forum. So
what about the trolls that are actually on the show? How do you keep them out?
With a big stick. So yeah, so those are my picks. Jeff, what are your picks?
Sure. So the first one's going to be hardware. I got a Fitbit Force recently, and it's really, really nice. The nicest thing about it is the sleep tracking. So I just hold down the button before I go to sleep, and then when I wake up, I can see like a graph of how I slept. Totally found out that I wake up every morning at 2:30 for a minute. No idea what's going on, but that's what I do. My next pick is a beer. It's New Holland Dragon's Milk. It's a bourbon barrel stout, and it is fantastic. They come in like the big bottles at the store, and one of those gets me pretty sleepy. It's 10%. So it's a bourbon barrel stout where they make the stout and they age it in the bourbon barrels. New Holland also makes a beer barrel bourbon, which is basically the reverse. And that's also fantastic.
That's awesome. I've never heard of anyone doing that.
So they just take the two barrels and swap them.
Exactly.
Makes a lot of sense when you say it that way.
Right?
It's like Amazon selling their excess CPU cycles, you know?
Yeah.
They're just, we had this bourbon barrel already. We might as well, do something with the bourbon that was inside of it or whatever.
Yeah, that bourbon had to go somewhere.
Yeah, well, I heard an interesting fact that the barrel of oil actually came from beer barrels. They used to ship it in beer barrels way back in the day. Anyway, well, thanks for coming, Jeff. It was an interesting conversation. Hopefully we helped a few people figure out how to approach these problems, because they're not always simple. Mm-hmm. I've found that concurrency, sometimes you just dig the hole faster.
Yes.
You do more than one thing at once.
You get 2 shovels.
So yeah, and if people have any questions, what's the best way for them to find you or get hold of you?
Sure. So the fastest is probably on Twitter, Slaunchaman, which is like the letter S, launch a man. I'm also that on app.net.
All right. Well, thanks again. We'll wrap up the show, and we'll catch you all next week.